Water is great, but too much of it is a disaster. And that is what NASA is predicting as it announces record flooding on Earth due to the shifting of the moon. How does the shifting moon cause flooding on the Earth, and where will the most effects be felt? Even though separated by hundreds of thousands of kilometers, the moon has huge effects on the Earth. In fact, scientists have claimed life would be completely different on Earth without the effect of the moon. But where did the moon come from? The prevailing scientific theory, the giant impact hypothesis, proposes that the moon formed when an object collided with early Earth. Spoiler alert, there was much more cosmic chaos in the early days of the universe than at the moment. Earth, like the other planets, formed from a remnant cloud of dust and gas orbiting the young sun. The early solar system was a violent place, and many bodies were formed that never advanced to planetary status, and one of these could have collided with Earth not long after the planet was formed. The Mars-sized body known as Theia collided with Earth, ejecting vaporized chunks of the young planet's crust into space, where gravity held the ejected particles together, forming the largest moon in the solar system in relation to its host planet. This type of formation would explain why the moon is composed primarily of lighter elements, making it less dense than Earth. The material that formed it came from the planet's crust, while the rocky core remained untouched. As the material drew together around what remained of Theia's core, it would have centered near Earth's ecliptic plane, the path the sun takes through the sky and where the moon currently orbits. When the young Earth collided with this rogue body, the energy involved was 100 million times greater than the much later event that wiped out the dinosaurs. For millennia, the rhythm of the moon's phases has guided humanity. For example, the calendar months you use to track time are roughly equal to the time it takes to go from one full moon to the next. However, the moon's orbit and phases can be perplexing. For example, the moon always shows us the same face, but its size changes depending on the moon's position in relation to Earth and the sun. While it is an Earth satellite, the moon is larger than Pluto, with a diameter of about 2,159 miles or 3,475 kilometers. That does not mean we have the biggest moon in the solar system, though. There are 4 other moons in our solar system that are even larger than our own. But the moon is slightly larger than 1/4, or about 27% the size of Earth, a much greater ratio than any other moon to its planet. This means that the moon has a significant impact on our planet and may even play a role in the evolution of life on Earth. To appreciate the effects of the moon on the Earth, it is necessary to understand what the moon is made of. The moon most likely has a very small core that is only 1 to 2% of its mass and 420 miles or 680 kilometers wide. It is most likely made up of iron, but it may also contain significant amounts of sulfur and other elements. The moon's rocky mantle is approximately 825 miles or 1,330 kilometers thick and composed of dense iron and magnesium-rich rocks. Magma from the mantle rose to the surface and erupted volcanically for more than 1 billion years, from at least 4 billion to less than 3 billion years ago. And the crust that includes the lunar surface is 42 miles or 70 kilometers deep on average. Due to all the large impacts the moon has endured, the outermost part of the crust is broken and jumbled, with the shattered zone giving way to intact material below a depth of about 6 miles or 9.6 kilometers. The moon, like our solar system's 4 innermost planets, is rocky. It's riddled with craters left by asteroid impacts millions of years ago, and the craters haven't eroded because there's no weather. The lunar surface is roughly 43% oxygen, 20% silicon, 19% magnesium, 10% iron, 3% calcium, 3% aluminium, 0.42% chromium, 0.18% titanium, and 0.12% manganese by weight. Water traces discovered on the lunar surface by orbiting spacecraft may have originated deep underground. They've also discovered hundreds of pits that could one day house long-term lunar explorers. Water is more abundant on slopes facing the lunar south pole, according to observations from the Lunar Reconnaissance Orbiter, or LRO. though scientists caution that the amount of water is comparable to an extremely dry desert. Meanwhile, another study suggested that the moon's interior could be rich in water. Now, many people are surprised by the effects of the moon on our planet. For example, early Earth spun much faster. Computer models show that Earth had a 6-hour day 4.5 billion years ago. Since then, Earth has been slowing down and our days have been getting longer thanks to our moon. Growth rings in fossil corals and shells, as well as ancient photosynthetic bacteria layers known as stromatolites, provide evidence of this. Stromatolites from 850 million years ago recorded a day length of about 21 hours. Fossil corals 400 million years ago lived on a planet with 22-hour days. Over time, the moon's gravitational pull on the Earth borrowed some of the Earth's spin energy, gradually propelling the moon into higher and higher orbits. The Apollo laser experiments prove that the moon is receding at a rate of 2 inches or 5 centimeters per year. The distance between the Earth and the moon grew while their spins shrank. Today, the Earth rotates once every 24 hours. It takes over 27 days for today's more distant moon to complete one full orbit around Earth. Our moon, like Earth, rotates on its own axis and goes through daylight and night cycles. The day and night cycles on our moon are longer than those on Earth. The moon spins on its axis once every 27.3 days. However, the moon takes the same amount of time to spin once as it does to orbit Earth completely. This means that observers on Earth always see the same side of the moon, that is, the near side. During lunar missions, the side not visible from Earth, that is, the far side, was mapped. The moon also contributes to seasonal stability on the Earth. The massive impact that created the moon may have tipped the Earth slightly, contributing to our North Pole's 23.5 degrees tilt away from straight up. This tilt determines our seasons, and the moon's presence helps to keep this tilt relatively stable. The moon's gravitational pull serves as training wheels for Earth's orbit around the sun. It maintains the Earth's axis at a constant angle. The Earth's stately progression through spring, summer, fall, and winter would have fluctuated greatly over eons if not for the moon. The moon also gives us a shining light. Of course, the moon, like the planets, does not produce its own light, but it shines because it reflects the light of the sun. While careful statistical studies have found no link between the full moon and strange behavior, the light from the full moon does make it easier for humans and other animals to see and be seen. Changes in predator success rates and prey animal foraging patterns have been documented as a result of this increased nighttime illumination, according to studies. Corals time their mating events according to the phases of the moon, and the tides change the coastal environment, which causes most other animal behaviors related to the moon. And by far the most consequential effect of the moon on our life on Earth is tides. The moon's gravity pulls the water on the nearest side of Earth towards it as the Earth rotates each day, causing a bulge. Due to centrifugal force caused by the Earth's rotation, the sea bulges on the opposite side as well. The Earth rotates beneath these watery bulges, causing 2 high tides and 2 low tides each day. The moon's orbit wobbles between a maximum and a minimum of 5 degrees relative to the Earth's equator every 18.6 years. This cycle, first recorded in 1728, is known as the lunar nodal cycle. The tides on Earth become smaller as the lunar plane tilts away from the equatorial plane, and the tides are exaggerated when the moon's orbit is closer to the Earth's equator. And according to NASA, rising sea levels caused by climate change combined with the influence of the lunar nodal cycle will result in a dramatic increase in the number of high tide floods soon. Benjamin Hamilton, a research scientist and the leader of NASA's Sea Level Change Science team, studies how sea levels respond to both natural and human actions and what this means for coastal populations. Prior to relocating to California, Hamilton lived in coastal Virginia where flooding was already a major issue, so he had a first-hand experience of the devastating effects of floods. According to Hamilton, these floods, exacerbated by the moon, will damage infrastructure and alter coastlines. Flooding will increase fourfold. Since the lunar nodal cycle affects every location on the planet and sea levels are rising everywhere, we will see an increase in high tide floods all over the world. And it's not just humans that will bear the effects of these floods. The lunar nodal cycle may present many challenges for humans, but it poses an existential threat to wildlife and coastal ecosystems. Rutgers University visiting professor Ilya Rocklin investigates the relationship between the lunar nodal cycle and salt marsh mosquito populations. She is not optimistic about the animal's chances. She explains that high tides flood mosquito habitats further landward when the nodal cycle is at its peak. Tidal flooding is more common during this time of year, bringing with it killifish, a group of several hundred species of minnow-like fish found in salt, brackish, and fresh waters. These predators will eliminate or reduce mosquito populations in the egg, larva, or pupa stages of development before the insects can fly out of the water where they are born. But there are usually fewer mosquitoes at the peak of the cycle, so tides may flood mosquito habitats very infrequently at the trough of the nodal cycle, giving them enough time to emerge and thus increasing their populations. That is bad news. And it's not just mosquitoes that suffer. Their abundance is a proxy for the health of many other species. Invertebrates such as shrimp, crabs, snails, grasshoppers, and other insects replace large mammalian herbivores in salt marshes. These in turn provide a significant food source for shorebirds and fish. But when combined with increased sea level rise, the peak lunar nodal cycle creates the real possibility of drowning salt marshes. And what happens when salt marsh invertebrates die? Well, the shorebirds, fish, and other species that rely on them suffer greatly. And this includes people, as salt marshes are vital to the global economy, serving as a nursery for a diverse range of marine life, including more than 75% of all fishery species. Salt marshes are also important for the environment because they can store carbon at much higher rates than many land-based ecosystems. And meanwhile, freshwater wetlands hold nearly 10 times more carbon than tidal saltwater sites owing to their vastness. Freshwater wetlands may face significant changes as a result of increased flooding caused by the moon wobble and sea level rise. Christine Hopfensperger is a Northern Kentucky University environmental scientist who studies the salinization of freshwater wetlands. She explains that freshwater coastal wetlands experience significant tidal fluctuations throughout the day and are far more biodiverse than their salt marsh counterparts. Many species are so-called specialists, so as the plants or first level of the food web change from a diverse community of freshwater plant species to a less diverse community of salt-tolerating plants, the animals that rely on these plants, including birds, terrestrial insects, and so on, may begin to change. Increased salinity has a significant impact on freshwater aquatic species which are pushed upstream to remain in fresh water. Salinization of freshwater coastal wetland will continue to increase as sea levels rise, and the more frequent flooding occurs, the more salinity affects our wetlands. Weather patterns would be very different in a world without tides. Tides are one factor that influence ocean currents, which move warm or cool water around the Earth. Warm ocean currents cause wetter weather, while cold ocean currents cause colder, drier weather. The lunar nodal cycle may also have an impact on one of the most important weather-producing phenomena on Earth. Normally, strong winds along the equator blow warm surface water from South America westward towards Indonesia, while cooler, deep water rises in its place. These trade winds are weakened or even reversed during an El Niño event, affecting weather all over the world. Warm surface water accumulates near South America's west coast, while cold water remains deep in the ocean. Wet regions are typically subject to drought, whereas dry regions are frequently inundated with rain, causing deserts to bloom. And a La Niña event, on the other hand, has the inverse effect of the El Niño event. The trade winds are blowing harder than usual, directing more water toward Asia. Cold waters that rise off the Americas coasts push the jet stream northward. As a result, winter temperatures in the south are warmer than usual, while temperatures in the north are cooler than usual. The El Niño and La Niña phenomena, when combined, form the El Niño Southern Oscillation Cycle, or the ENSO cycle. The Southern Oscillation part refers to the change in sea level air pressure over the equatorial Pacific Ocean. The switch between El Niño and La Niña may be influenced by a subsurface ocean wave driven by lunar tidal gravitational force, according to the Ohio State University scientists. Interestingly, and so can be predicted by studying the Moon's 18.6-year nodal cycle. There is a known lunar nodal effect on the sea surface. The Moon's gravitational pull influences tidal currents and thus the movement and mixing of the upper layers of ocean water. This is especially true of the North Pacific. But what about the Moon's effects on ice, land, and air? The Moon also influences polar temperatures and contributes to fluctuations in Arctic ice extent. However, in this case, the Moon's influence is not its 18.6-year nodal cycle, but rather its more familiar monthly variation in the amount of light reflected from it as it waxes and wanes. Satellite measurements show that the poles are 0.55 degrees Celsius warmer during a full moon. One thing to note is that the Moon generates tidal currents and waves both at the surface and deeper in the ocean. These currents and waves may either melt or break up sea ice, either as a result of the transport and mixing of warmer waters or as a result of straining motions acting to tear apart the ice into smaller pieces, which are then more susceptible to melting. But the ocean's water and ice are not the only places on Earth where tides occur. In addition, the Moon has a tidal effect on both solid land and the atmosphere. Earth tides behave similarly to ocean tides. The land deforms and bulges in the same way that the sea does, and this has been linked to volcanic activities and earthquakes. And energy flows from the upper to lower atmosphere are caused by atmospheric tides, as are changes in atmospheric pressure. Air pressure changes caused by the Moon's position were first observed in 1847. The gravitational forces of the Moon cause bulges and oscillations in the Earth's atmosphere that are similar to those seen in water. And changes in atmospheric pressure are associated with higher air temperatures, which means the air molecules can hold more moisture in the form of water vapor, lowering humidity and thus the chance of rainfall. As a result, lower pressure is associated with cold, wet weather, while higher pressure is associated with calmer, more pleasant weather. However, the Moon's influence on precipitation via atmospheric tides is minor, as other factors such as solar heat have a much greater impact. So the amount of rainfall is affected by lunar forces, but only by about 1%. When the Sun and Moon are aligned, it rains slightly more than it does 6 hours earlier or later, so the Moon's pull only affects when it rains, not how much it rains. The Moon's influence on the Earth is sometimes subtle and sometimes profound. In fact, some scientists believe that the Moon created life in the first place. But even if not as dramatic, the Moon helps to stabilize the Earth's climate as it spins on its axis. The Earth would wobble more erratically if it didn't have the Moon. The poles would shift significantly in relation to the Earth's orbit. Seasons, days, and nights would all be drastically different. However, the tides that may have begun life on Earth are also pushing our Moon away from us. Because of the tides it causes on Earth, the Moon moves away from the Earth by nearly 4 centimeters every year. Because the Earth rotates faster than the Moon, the gravitational tug of the tidal bulge pulls the Moon along faster. As the Moon accelerates, it is flung outwards and its orbit expands. It's similar to standing on a playground roundabout. The faster it spins, the more you feel like you're being thrown outwards from the center. The effects of flooding in the coastal areas are significant, and not only are they significant, but they're also already occurring. This is why the National Oceanic and Atmospheric Administration at NOAA has carried out a study of what rising sea level means. Interestingly, the results coincide with the effects and timeline of the Moon's wobbling. According to a 111-page report released by NOAA and 6 other federal agencies, seas lapping against the United States shores will be 10 to 12 inches higher in the near future, with parts of Louisiana and Texas expected to see waters 1.5 feet higher. And as you can expect, floods caused by today's sea levels, weather patterns, and infrastructure are expected to occur more than 10 times as frequently in the next 30 years. In other words, a single flooding event likely to damage property or commerce in coastal areas of the southern United States every 4 to 5 years will be expected to strike 4 to 5 times a year. According to NOAA's administrator, this report should be a wake-up call to the United States. Top White House officials agree with this warning. This new data on sea rise is the latest confirmation that the climate crisis is flashing code red. Experts have warned that the cost will be high, pointing out that the coast is home to much of the American economy and 40% of the population. There will be a high human price because 40% of the population of the United States lives within 60 miles of our coastlines. There will be a wide range of effects along those coastlines, but there's no denying that a significant portion of the US economy, revenue and tax base is right there in the middle. The projected increase is especially concerning given that sea levels along the Atlantic coast rose at the fastest rate in 2,000 years during the 20th century. The worst of the long-term sea level rise caused by melting ice sheets in Antarctica and Greenland, however, is also waiting in the future. Warmer water expands and melting ice sheets and glaciers swell the volume of the world's oceans. The report is the equivalent of NOAA raising a red flag about accelerating sea level rise, according to Andrea Dutton, a geoscientist at the University of Wisconsin-Madison who studies sea level rise. She says current coastal flooding in the United States will be taken to a whole new level in just a couple of decades. Because of sinking land, currents, and water from ice melt, sea level rises more in some places than others. The United States will experience a slightly higher sea level rise than the global average, and the Gulf and East Coast will be the hardest hit, while the West Coast and Hawaii will be hit less severely. Residents can expect nearly 25 inches or 0.63 meters of sea level rise in Galveston, Texas, and just under 2 feet or 0.6 meters in St. Petersburg, Florida, compared to 9 inches or 0.23 meters in Seattle and 14 inches or 0.36 meters in Los Angeles. While higher seas cause far more damage when storms like hurricanes hit the coast, they're also becoming an issue on sunny days. Cities such as Miami Beach, Florida, Annapolis, Maryland, and Norfolk, Virginia already experience a few minor nuisance floods during high tides each year, but these will be replaced by several moderate floods per year by mid-century, causing property damage. Many of the major U.S. East Coast metropolitan areas will be increasingly vulnerable, but the western Gulf of Mexico coast will be hit the hardest by sea level rise. 16 to 18 inches or 0.4 to 0.45 meters. That equates to more than 10 moderately damaging sunny day floods and one major high tide flood event per year. And by 2050, the eastern Gulf of Mexico should expect a sea level rise of 14 to 16 inches or 0.35 to 0.4 meters and 3 moderate sunny day floods per year. The southeast coast should experience a foot to 14 inches or 0.3 to 0.35 meters of sea level rise and 4 moderate sunny day floods per year by mid-century, while the northeast coast should experience 10 inches to a foot or 0.25 to 0.3 meters of sea level rise and 6 moderate sunny day floods per year. And by mid-century, the Hawaiian Islands and southwestern coast should expect 6 to 8 inches or 0.15 to 0.2 meters of sea level rise, while the northwest coast will see only 4 to 6 inches or 0.1 to 0.15 meters. The Pacific coastline will experience more than 10 minor nuisance sunny day floods per year, but only about 1 moderate flood per year, with Hawaii receiving even less. According to the report, the United States will experience an average of 2 feet of sea level rise by the end of the century, with more in the east and less in the west. But is the world prepared to deal with flooding due to the moon's wobbling? Let's hear what you think in the comment section below.